All right, folks, let's pick up where we left off last night. Last night we were debugging some code for day number 19 that didn't quite work, and hopefully in the in the light of day we can figure out what went wrong. So to review, the challenge here is to find the rotations and the positions of a variety of different ones of these probes. And they can potentially be offset from each other, and also that they can be rotated from each other. But the way that you identify points that are the same between two different probes is if the deltas between different points if the deltas between two different points are the same, then you know that they are potentially unique points. So I realized that I had one potential bug here that could potentially result in incorrect matching. Specifically, this here is an undercount, right? That if you have that we actually need to have at least 12, not just pairs that line up, but we need to have 12 unique points that all line up. That it is possible to incorrectly trip this. And that I think is the bug that I was stumbling into, which is right. So the problem is this. Something like this is the issue, where I was incorrectly identifying things as matching each other. A thing that my spouse said this morning tipped me off to this. My spouse was asking, like, hey, like, how do you know for sure that something is a match or not? Right? Like, are they necessarily in each other's field of view? But there isn't necessarily a field of view going on here, so much as a there isn't so much a field of view going on here as because everything can see everything, right? Like it knows the positions of many things, right? Like they don't have a finite range. It says beacons that are most 1,000 units away. Okay, that actually is potentially an issue here. So Ellie was pointing out that you might have something that turns up to be relatively close together, but is not. So we haven't enforced that 1,000 constraint yet. And we also have not reported, and also here we're incorrectly detecting double counting matches. So we're going to fix that now. Something like that ought to do the trick. I think that should do it. Okay, so now I'm still finding this, and I'm still getting inconsistent positions, but I think this is more likely to be true. Yeah, okay, so I've got 12, 12, 12, and 12 here. So that's good now. So I'm pretty sure that I have my matches set up correctly. Now that I've checked that condition. Okay. So why is the diff not being consistent? I'm not sure what's going on here. Okay. almost 1,000 units away. Yeah, I haven't used the 1,000 condition yet, and I think that that might be important. So I'm worried a little bit about my matrix math. And see, we dealt with the mapping matrix fine, I think. I hope. Yeah, that looks correct. So the question is, did I do my matrix multiplication correctly? You can kind of see that I'm making the gesture of the of how you do a dot product in my head. Just checking these things. Let me just check this theory. Okay, so for the example, scanner 4 overlaps with scanner 1, and they have 12 beacons that they both detect relative to scanner 0. So I think, yes, I think given what I'm seeing here, where the problem is that I'm not correctly identifying scanner 4, right, if I run this program again, what we see is scanner 0 is of course in the correct place, scanner 1 is in the correct place, but that scanner 4 is in the clearly wrong place. Yeah, scanner 1 is correct. Scanner 2 is also in the incorrect place, but scanner 3 is in the correct place. Right, so it's these two that are wrong. And the reason that they're wrong is because they are relative to other coordinates. So as mentioned on stream last night, that someone pointed out that I might have a problem with double adding the offset. So what I'm going to do is I'm just going to print out reference 1. And reference 2. And see whether they line up with any of these that are mentioned here, because that'll give me some insight as to what I'm doing wrong. Okay. So here, it's correctly detecting 534 minus 1912 and 768. And it's also correctly detecting negative 739, negative 1745, and 668. So yes, so this tells me that I'm identifying the matches fine of which points are matched. So that's not my problem. My problem is then converting that to knowing what the position is of yeah, my problem is then converting that. So the beacons have been correctly identified. The problem is that my position calculation is incorrect. And that's probably because scanner 1 is rotated, and still and so is scanner 4. So we have the diffs. So yeah, the problem is in either this code here, where the mapping is wrong, or the problem is the subtraction. The subtraction worked fine before. So I have the absolute coordinate, but having the absolute coordinate is not enough. Okay, so I'm pretty sure that the problem is applying the mapping. Okay, so that means I need to check my matrix math. I think that's I'm pretty sure that's the problem. So why is it that applying two rotations to each other is not working? In fact, let me take a bet here. I'm going to bet that this is yielding a nonsense result. Okay. So the first two that I identify that do not have inconsistencies look like this. But this third one here does have an inconsistency. This looks on the face of it like it should be a reasonable thing. I'm just curious, is this mapping map aligned axis map? Is this operation commutative? Oh. So order doesn't matter here, but it does matter here, because you can get different results depending upon the order in which you apply these operations. Okay. So given that circumstance, let's try this. Okay, that's wrong. Oh, whoops. Something like that should do the trick. Okay, now I get two sets of inconsistent positions, which is interesting. Okay. That's fascinating. So maybe when I find a pair... Ah. I think I see the problem. So I think the problem is that if the pair order is reversed, then the order of the mapping also has to change. That might be the case. So let's try this. Something like that might do the trick. This is ugly and I'm not proud of it, but maybe this is what's needed. Nope, still getting inconsistencies. Better now, though. Scanner 3 is now -92. Scanner 4 is wrong. Okay. So I've got 68, -1246. That one's correct. This one still is wrong. This one is right. And then... this one is wrong. Okay, so no, that's not it. Yeah, okay. I've got a feeling I understand this. What would happen if I inverted the axis map? Like, what would happen if I did this? Where is my definition of a mapping matrix? It's a 3-3 int. But I said earlier, we're not allowed to have -1, -1. Yeah, I'm pretty sure I see the problem. I'm just not sure how to solve this. Right, I'm pretty sure there is a that if you have to flip it around, then you also have to yeah, if you have to flip it around, I think the mapping also has to be adjusted in some fashion. Am I allowed to... I'm allowed to invert 2 dimensions at a time, or 1 dimension, but not all 3 dimensions as I'm reading through this. No, this one is... Where was this? Where is the one that has all 3 -1s? There is definitely one in here that is -1, -1, -1. That was in the third group. 1, 2, 3. -1, -1, -1. Yeah, okay. So if that's the case, yeah, in fact, there's one here that's also all -1s. Okay. So assuming that this is the case, then, let's create something that will invert a mapping matrix. So something like this should do the trick. Okay, so let's suppose this hypothesis is correct. Still inconsistent. Okay. Yeah, okay, so I know the problem is that I'm getting the correct points here. I'm just failing to walk it back correctly from there. Yeah, let's just check this. So just triple check this. Pretty sure this should be a no-op, but just to be sure. Yeah, okay, is one of these correct now, potentially? So scanner 4 should be at -20, -1133, 1061. Okay, given I know this, let's try printing these and seeing... so when I talk about walking it back correctly, let's show you what I mean. Let me just make sure that this is correct. This is the aligned deltas. Yeah, so the pair here is going to be my original pair. Yeah, because that's looked up in my mapping. Yep, that's correct. Okay. So here's the thing, right? I've identified here that there are that one of the points that's implicated here is the one at -739, -1745, 668, right? This is in the overlap between scanner 4 and 7 and scanner 1, and I'm correctly identifying it here. The problem is that when I'm trying to flip this back to figure out where scanner 4 is located, I'm not flipping that back correctly. Right? I've also found -589, comma... Wait, that's not right. that, right, so make sure I'm printing this, I'm printing the correct number of things. Right, so the problem, as I said, is that, okay, so I'm printing three things, right? I'm printing the reference, and I'm printing the two potential ways to, right, like the reference point that's in the overlap, and I'm printing the two, I'm printing the two offsets. That it could potentially be. Right, so this one is -735, 668. So what I want to do, right, is from here, right, there should be some combination that produces a -20, right? So what produces the -20 here is matching these 2 points together and saying that I'm going to take -739 plus 719 produces -20, right? And that taking -1745 plus 612, I think, produces -1133. And then that leaves the last pair, which is 668 plus -393, which produces, -668 minus -393 produces 1061, right? So the offsets I'm looking for are essentially, right, like let me just paste these in here, right? So the value I'm looking to get is this set of values, right? So essentially I have A equals this, right? B equals this. And my transform matrix is just wrong, right? That's the problem. Because what happens if I take A of 0 plus B of 1 is I get -20. And then over here I have A of A of 1 plus B of 2. And I have A of 2 minus B of 0. Right? Yeah. Right, so that yields the coordinate that I'm supposed to be at, which means that this transform matrix should look like, it should look like one, what does this matrix look like? So I'm taking, yeah, so the operation I need to perform on B, sorry, it's always going to be A of 0, A of 1, A of 2, right? Like those are fixed points, but what I want to express is which elements do I take from where, right? And what's happening is this should be 0, 1, 0, right? 0, 0, 1, and then this is -1, 0, 0, right? This should be the transform matrix that I'm looking for. But instead, the transform matrix that I'm getting is here, let's do this. Okay, so I don't think I actually need the invert. I don't think that's my problem here. There's something that's gone wrong here. So position relative to scanner 0 of overlap. These are the candidates. Okay, so now this should... Right, so what I have here is... Oh, this resulted in a different one because it evaluated in a different order, but that's fine. But I can see that this is still found, right? Like the problem is just okay. This is now the same one, right? So position, right? Like this is the same 739, negative 1745, 668, right? So the problem is that this matrix here is wrong in two aspects. First of all, it's wrong in that the elements all need to be flipped, right? That the order is wrong. So it should start 0, 1, 0, 1, 0, 0, and then negative 1, 0, 0. But here, what I'm seeing is these need to be reversed, and then the last one needs to be flipped, I think. You know what? That's fine. Maybe we don't need to trust this. Maybe having identified the point, we can just repeatedly... Let's try this and see whether this special case works, and then we'll see. Okay. So let's try doing the invert. So where is the invert function? So that's not correct. So what we're going to do is two, 1, and 0. And then also let's flip try that now. So now oh, that's fascinating. How did that happen? Right, essentially the problem that I know that I have is that let's comment out the invert for now. I have to find, because this doesn't always predictably find the same points. Right, here's another example where we know that if I take actually, what results in 423 out of this? How do I get 423? I'm so close. I'm literally so close. It's just a little bit of matrix algebra that's standing in my way. I'm tempted to brute force it and just try every possible transform until I get a consistent result, but I know that that's not the way that this is supposed to work, and therefore I'm hesitant to do it. Let's keep trying until I get the example that I know that I'm looking for. Yeah, okay, so I think just this transform matrix is wrong. Yes, the problem that I'm getting wrong is the transform from 0 to 1 and then from 1 to 4. That the transform from 0 to 4 is wrong. That is precisely the problem. Right, so what I've figured out is that this here is supposed to be the result that I get, right? But what I'm actually getting is my code is actually spitting this out. Right, it's spitting out the completely wrong transform. Yeah, sure. So the correct transform that I know by checking the maths by hand is this one. But the transform that my code is giving from matrix multiplying together from 0 to 1 and then from 1 to 4 is this. Uh, 0 to 1, I'm pretty sure is this guy. Here, let's try. Let me do this really quick. That way I can display it. Okay. Here. This will work. Yeah, so here's the map between... In fact, what's interesting, right, like, is the overlap between scanners 3 and 1 is fine, I think. 0, 1, 2, 3, negative 92, negative 23, 80, negative 20, yeah. So even applying from 0 to 1 and 1 to 3 works, but not from 1 to 4. which is an especially infuriating bug. And then that error is carrying over into the overlap from 4 to 2. Because once you get fours coordinate wrong, then you mess up the position of 2, even if you don't mess up the orientation of 2. Titan CNC says attempt to reverse the cross product to see if you get the original. I would do that if I remembered enough linear algebra as to how to undo a matrix multiplication. Oh, 3 and 1 doesn't swap the axes, but 4 and 1 does. Huh. Okay. Okay, so my problem you're saying then is with the axis swapping, that code is busted? Oh yeah, you're right, because those are -1, 0, -1, -1, 0, -1. Whereas this one is actually trying to swap the axes. Yeah, okay, I buy that, but... All right, let's try this. Maybe it's possible that I need to try both inverted and non-inverted. Yeah, okay, I think that might be it. The inverse of a rotation matrix is its transpose, yes. We're going to try this. Let's try this. I'm going to do this. Let's do this instead. I don't love it, but I think this is probably my best option here. All right. All right. Let's see whether that works. That's clearly wrong. Okay. Oh, that's because that's wrong. Okay, now I get 91. Now I don't have any inconsistencies. Or my debug code. Yeah, exactly. I don't have... Okay. Just put this debug stuff in here. Is that loop supposed to loop? Oh, yes, that loop is supposed to loop, so that is actually a good call. There we go. Okay, now I'm back to having insufficient overlap. And now I think I've applied what should be the correct transform matrix. Wait, no, that's wrong. No, that's wrong. 0, 1, 0. Oh, 0, 0, 1. Okay. So now my inverse is wrong. Yeah, there's a better way to handle matrix invert. Someone help! How do I invert a matrix? Yeah, but how do I get the 3? How do I get the 3 by 3 matrix? Oh God, calculate the fucking determinant? Really? Oh dear Lord. Yes, this code here is wrong, but I'm pretty sure once I get the yeah, once I get the inverse done, we'll be fine. Good Lord. Okay, well the good news is the magnitude is always the same. Hi Flurry. Flurry, shush. Okay.
Hello. Hello, loudly. Unfriendly hound. Drive safe.
Okay. How does this work? Not sure I follow this. Form row matrix operations. So it looks like the identity matrix. So they're subtracting rows. Okay. There's a missed hint. Inverse of a rotation matrix is its transpose. What is... Oh. Oh. Okay. I see. So what you're saying is that it will look... Oh, someone's attacking one of my structures in Eve. That's exciting. Hi, PagerDuty. Yes, I am a giant nerd. I get notifications of structure attacks in Eve on my cell phone. I will dispatch someone from my alliance to go deal with that because I am currently otherwise occupied. Okay, so because this is straightforward enough, I can just do it. Do it this way. For C in range MR. Ret CR equals MRC. Okay, does that do the trick? No, that still has a problem. Oh, we're getting closer. Look at that. Yeah, okay, so now the problem is just that I need to flip the last row. For some reason. I don't understand why, but I need to flip it. If okay, let's try that. Okay, now that yields the correct 89. I don't understand, or no, it yields 79, not 89. Why? Why? What has gone wrong now? So now I've got the correct coordinates, do I not? -1384. What? Whoa. -92, -2380. Yep. Okay. Okay, so now I'm getting consistent results. But they're wrong. Scanner 3 is at -92, 2380. Scanner 0 is correct. Scanner... Okay, so that's correct now. But why are these wrong, even though they're now consistent? Yeah, 0, 1, and 3 are all correct, no axis swap. run this and see what happens. Oh. Right. That's a printf. This is a printf over here. Okay. So for instance, this one, negative 635, negative 1737, 486, that's correct. So by applying the transform matrix to one of these 2 points, I should be able to get what I want, right? I should be able to... Oh, I see the problem. So the position is correct, but we haven't updated the axis map, I don't think. But we did update the axis map. It's right here. And we even printed it out. You said 3 is correct, but out of order now? Scanner 3 is negative 92. No. Right, here's what's getting me is let's bail out and reset this. Right, so what we have is the claim here is that if I take this, right, negative 635, negative 635, and for this first one, what it's telling me is I need to take negative 615 and add it, right? Wait. Yeah. Plus 615, that yields negative 20. So that should do what we expect, but instead, it's producing the wrong number. Oh. The reason that it's doing that is that my inverse needs to, because I'm doing a subtract, not an add. Yes, I think my invert is wrong, and I should be doing this. Now let's try that. Okay, now I get 79. That's correct. Okay, cool. So now let's take out a bunch of this debug output. And let's leave in the could not find consistent position. Now let's run it on our sample input just to make sure it produces clean output. And now let's run it on my real input. Whoa, that's exciting. Okay. What have I done wrong here? Because now this code solves the sample input fine. And it finds all of the positions. Right? 68. Negative 20. 1105. Negative 92. So now I must be doing something that doesn't fully generalize. Okay, so my code does solve the... Okay, 5,000 people have solved this before me. I can do this. This code clearly works now on the small input. Why does it not work on the bigger input? The instant we can't find a consistent position, we should bail. And we should debug further. That's what we need to do. Okay. All right. So let's just print this and see what's wrong with it, to see what's wrong with my transform matrix. Okay, that's now really infuriating that I've special cased a thing that should not be special cased, and yet. I'm gonna look these over one more time just to make sure that I got those correct. Yep. 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 And yep. Okay, we're here now. Just making sure that I'm not missing anything here in this list of transforms. Yep. And yep. Okay, so we're on this block now. Yep. 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 Yes. Yes. And yes. Okay, so my general transforms is correct. Okay, now, is there the possibility that I have messed up my matrix multiplication in a way that works for one input but fails on the other? Is my subtraction doing what I expect it to be? Yeah, my subtraction is doing what I expect it to be. Okay, so let's check my matrix multiply now. Almost be better to encode this as code, wouldn't it? How do I express this as code? Guess I have to do the 3-rolled loop. Okay. This is ret RC plus equals M RI times N I C. Okay. Okay, that's cleaner for sure. Yep, still yields correct results. Now let's try running on my real input. Nope, still cannot find a consistent position. Okay. So maybe my theory here, that I'm supposed to be able to take the mapping from one to another and I'm supposed to be able to compose them. Maybe that theory is wrong. Oh. Wait, I think I see the problem. I think the problem is this here. This is not right. I'm not supposed to invert the entire matrix. What I'm supposed to do is I'm supposed to do this. Yeah, okay, that's going to be correct. So now I can tailor my invert function to do what I expect it to do. So the invert function is just literally supposed to do that. Okay, let's run in my sample input, because I hard-coded that case and felt weird about doing it. Okay, that still yields the correct result. There we go. All right. That was it. That was it. Okay. So now I have another problem, which is let's return here. Okay, how many of these did I fail to match? Okay, I was not able to match 22. Is that the only one not matched? Okay, I'm just missing the mapping for 22 now. This is interesting. Okay, well, I'm going to try putting this in and see whether it's wrong. It's not correct. And now I am locked up for 5 minutes, but that's fine. That'll happen. Because I have some debugging to do. But this largely is working now. So the problem is if I is 22, let's find out what the count is. To see why it is not reaching the threshold. On probe 22. Looks like we are getting more structure attack notifications, but that is fine. Length of matches. Okay, let's try this. I am so close now. I can taste it. Found 6 overlaps. Oh, 11 overlaps. That's close, but almost. I've acknowledged the page. So the fact that I found 11 overlaps but not 12, I'm wondering whether I can just solve this by getting sloppy. So let's do this for now and see what happens. Okay. I have 2 minutes left to wait, but it did identify everything with consistency, so I'm curious. Yeah, why do I have the off by 1? So this is the index in the pairs. Right, this should be 12. We are short 1 match here. So it's possible I have messed up pre-computing the pairs. Which would be here. But that seems like that should be fine. But whatever, that seems to be okay. Let's remove this excess print now. Oh, whoops. All right. Right. Well, if I get the right answer the wrong way, I might be happy with that, happy enough with that. That's correct. Okay, on to part 2. Using the Manhattan distance, how far apart are the 2 scanners? Okay, what's the largest Manhattan distance between any 2 scanners? That's easy enough. I will debug at a later time why I have this off by 1, but I am content to just solve and be done for now. Okay. N and M. Same deal here. If J is greater than or equal to I, then we break out of here. Otherwise, N sub M. And then for some hint, if diff x is greater than 0, then sum plus equals diff x, else sum minus equals diff x, and then we just do it for all 3 dimensions, and that should do it. And z, z, z. if sum is greater than max distance, sum equals max distance, or distance, max distance equals sum. Okay. Oh, it's not sub, it's n dot position, sub m dot position. Oh. And of course it'll be, I have to dereference the pointer. That's correct. Done. Okay, cool. That was it. That was fun. Yeah, I'm glad I could figure out the trick. So there's probably a slightly tidier way to do this, mainly by abstracting this into a function. I kind of don't care because I only use that function once. I'm not sure why I'm short one match, but it seems to work well enough in practice because Eric didn't throw anything mean in, so that's fine. All right. Day 19 solution. All right, I'm going to push this to GitHub so folks can have a look at what I did. And I will see you on this stream tonight. Cheers, folks. See you at 9 p.m. Pacific time.